Hi, I'm Neil, a DevOps expert, and today I'm going to go through the Black Friday challenge. We're going to talk about this time of period of everyone's e-commerce life. It's a high traffic, resource intensive time, and you've got to have that balance between high turnover and high costs of cloud resources. So let's go through the steps of planning, the real-time monitoring, auto-scaling in action, and the financial controls. So we've got a couple of weeks before Black Friday. Hopefully if you're watching this video as it comes out. If not, we can analyze some stuff. Anyway, pre-planning. We can look at maybe last year's stats. Have we got that information of how busy the website was last year? Analyzing the previous Black Friday traffic will help us understand what might happen this year. We can run load tests against the app in our pre-app development environment or our specific performance environment if you have one. See how much stuff you can throw at the app before it breaks. Maybe that'll give you an indication of where a bottleneck is or where a bug fix can happen just to make things go faster. We can calculate the resources required to run at specific levels and therefore how much it's going to cost us. We can also use this data to set up thresholds so that we know when stuff's getting busy. And of course we can use GitOps in order to help us set all this stuff up. So we're in the period of Black Friday, and so we should be doing some monitoring so that we can see and have some clue as to what's going on. What should we look at? There's some key metrics to watch. Request times and request rates. So this is how many requests we're getting per second, or even smaller if it's a really big site, so that we can understand what's going on with our particular server. Each one of those requests will also have a response code. Those response codes will be delivered after a certain response time. So we can see if certain requests come in, how long they take to run, and what the eventual code is resulting from that request. Most of the time, it will be a 200 request, because that means everything went fine and we delivered the content back to the requestee. If we've got errors in those, then we should keep a track of those. An error might be a bug, or it might be a bottleneck somewhere else. Of course, whilst this is all happening, we can also check the CPU and memory usage that our app is having on the system. Maybe adding more CPU, or maybe adding more memory will help us next year. Or if we've got it set up, as you'll see in the next section, help us right now. Those error rates are important though. Some errors are expected at a high level, just because stuff always breaks. You must be ready for that. But these error rates can increase when certain stuff is hit. Maybe it's a specific microservice in your system. Maybe it's a specific slowness of the database or something else that's causing it. But with these error rates, as they increase, it gives us more data to make the system better next time. And whilst we're also running the system, we can work out how much it costs us. The cost per hour, cost per minute, or even down to the cost per request. This will give us more information so that we can plan again later on, or make a real-time decision as to whether we need to scale immediately. Which leads us on to auto-scaling in action. There's two types of scaling. I'm sure you've heard of them. There's horizontal scaling and vertical scaling. Horizontal scaling is where we take the same cookie cut process, be it a server, a virtual server, or a container, or something like that, and we just stamp out more of them in a horizontal direction to give us more of those things. So we can go from 2 servers to 4 servers to 8 servers to 32 servers, however many it takes for our particular workload. There's also vertical scaling. Vertical scaling is where we make the resource bigger. So that virtual server, we give it more memory or we give it more CPU. And we make it bigger that way. And there's pros and cons depending on where you are and what layer you need to do in order to fix this sort of thing. It's quite common for web servers or for proxy servers to scale horizontally. But for database servers, it's more common to scale vertically. And of course, you can blend the two together. When we're talking about scaling policies, we want to know when we can scale up and, more importantly, when we can scale down again. You might have a policy set that says CPU usage above 70% for 5 minutes. Let's scale up. Let's scale up and go horizontal, add another unit into our server farm. And then you want to scale down. If it goes down to, say, 10%, CPU usage, then we can scale that instance down. However, don't be fooled, that sentence holds loads of dragons. Scaling down is hard. What do you do if there's a request already in flight? Let's make sure that that node isn't handling any traffic before we suddenly kill it. The other gotcha is if we're scaling down, we don't want to be scaling down and then scaling up and then scaling down and scaling up. So we want a sort of scale down cool off period to make sure that the spike really has gone away and we're not just idle for a few seconds. And as we're talking about load and scaling, then have you thought about regional distribution? Some providers will let you put servers even closer to the customer. If you're in the States, then you might have some servers on the West Coast and more servers on the East Coast as a distribution for where that traffic is. And lastly, financial controls. Scaling up costs more money. So we want cost monitoring and cost alerts in place. This enables us to understand how much we're spending in real time and whether we're spending too much or not enough based on our forecasts. And those alerts will tell us when we hit certain thresholds. And our configuration of code will usually have a maximum already defined within it. You can have your system alerts where they will say, right, I want you to scale up until you hit a maximum of 32 instances. At that point, it doesn't even matter if you're 70% for 5 minutes. I don't want you to scale up any more than that. Sometimes doing this is okay. A customer will hit your site, it will say, I'm sorry, we're busy, try again in 5 minutes. And for your business, that might be okay. Another thing that we can use to control costs is where there might be the possibility of paying up front for something for a discount. We know we're going to be busy, we know that we're going to use a certain amount of resources, so will our supplier give us a slight discount if we give them some money up front for that? In Amazon land, this is called reserved instances. And so we can reserve an instance up to a specific amount of usage, whether it's going to be used all day, 100%, or maybe half the day, 50%, and for how long we want that instance reserved for. 1 month, 3 months, a year, 3 years, depending on what we expect the workloads to be. If we're expecting particularly spiky traffic or very short durations, maybe spot instances will be useful here. Spot instances can be very cheap compared to the on-demand price, and will provide you with a cheap saving and some very temporary, and I mean temporary, resources. These things can be shut down with 2 minutes notice. And finally, when we're talking about costs, you'll want to tag resources so that you can attribute the cost to a specific project or something based on the tag. This enables us to analyze the costs even further. So here's some pro tips and best practices for you. Don't optimize first. Load testing is your friend. Run the load tests, find out what needs to be optimized, then optimize it. Don't just guess. You're wasting time. Find the limits and the bottlenecks, and that'll tell you what you need to optimize. Also, some things are too expensive to scale, like an Oracle database. They charge per CPU, so that's got a lot more back-end costs just for a temporary change. Maybe there's a better way. You can use layer caching, like put in some sort of database cache, a query cache in front of it. Or just, if it's right, putting those into some sort of queuing system so they can be written later on when the system can just catch up. Understand your budget. Scaling will cost, so you need to understand how much budget you can play with to set those top limits like I mentioned earlier. And traffic management. Sometimes it's okay to put a customer in a queue instead. Make them wait a little bit longer if you are hitting the top limits of your resources. Oh, and top tip, don't deploy changes to your infrastructure at peak times. Even if it's really struggling, resist the urge to change anything, because then you might give yourself proper downtime. After the event. So once the event is over and the dust is settled, be sure that everything is scaled down. You don't want to be paying for something that you're not using. Review the effectiveness of the scaling you had in place, particularly with those error rates, and analyze the costs. How many transactions did you do? How much did it cost you to do those transactions? Was it worth the extra cost? Only your business can tell you that. I hope that gives you a great idea about what you can do about the chaos that's coming up in a couple of weeks' time for Black Friday. If I can help in any other way, reach out to me, and I'm sure there's some good stuff in the description. And I'll see you next time, and may all your deployments be smooth.